So we've talked about writing equations of lines in both point slope and slope intercept form. We also want to talk about writing different types of equations of lines like perpendicular and parallel lines. Parallel lines are lines that do not intersect. Therefore, parallel lines must have the same slope but a different y-intercept. If they're parallel, they're going to continue to rise and run at the same rate as another line, so it's got to have the same slope. So for example, y equals negative 2x plus 6 is parallel to y equals negative 2x plus 4. Both of them have the slope of negative 2, therefore they're parallel. I want you to write 3 lines parallel to y equals 1/3 x minus 5. Now there are an infinite number of correct answers, so I just want you to write 3 of them. Now if we look at our example here, or the examples I gave you, y equals 1/3 x plus 6, y equals 1/3 x minus 12, y equals 1/3 x plus 20. We even have y equals 1/3 x. As long as your slope is 1/3, they will be parallel. Make sure all of your examples have a slope of 1/3. Now, since we know how to write equations of lines from a given point and the slope, we can easily write equations of lines parallel to a given line using point-slope form. So let me look at an example. Write a line parallel to y equals 3x plus 7 and passes through 6, negative 1. Well, remember for point-slope form, we need a point, which we have, 6, negative 1, and we need the slope, which we know because it's parallel, it has the same slope as the line it's parallel to. So the slope in the example is 3. So the slope of our new line is also 3. So we're going to use point-slope form, substitute in our values. The y value is negative 1. We know the slope is 3. And the x value is 6. So the best way to write this is y plus 1 equals 3 times x minus 6. Now we have a line that's parallel to our given line. I want you to try the second example. Pause the video and try it and see if your answer matches mine. Okay, so again, we know the slope is going to be negative 1/4. So we're going to fill in our equation. Y minus 5 is the y value, equals negative 1/4 is our slope, and x minus 2. There's our equation that's parallel to our given line, which means they will never intersect my 2 lines I have. Perpendicular lines are lines that intersect at a right angle. Perpendicular lines do not have the same slope because they're going to intersect. Their slopes are opposite reciprocals. Now we talked about reciprocals when we dealt with division of fractions back in 6th grade. Reciprocals are flipping the numerator and the denominator. Opposite reciprocals means you're also addressing the sign. If it's positive, it's going to be negative. If it's negative, it's going to be positive. So you're not only flipping it, you're flipping the sign as well. So for example, y equals negative 2x plus 6 is perpendicular to y equals 1/2 x plus 5. Well, negative 2, when you flip it, becomes 1/2, and it's a positive and a negative, so those are opposite reciprocals, which means those lines are going to intersect at a 90-degree angle. Write the slope that would be perpendicular to the following slopes. Pause the video and try these 3. Alright, the opposite reciprocal of 2/3 is negative 3/2. The opposite reciprocal of negative 9/5 is positive 5/9. And the opposite reciprocal of 8, negative 1/8. If you have questions, please ask in class. So, since we know how to write equations of lines from a point and a slope, we can now write an equation of a line that is perpendicular to a given line. Write a line that is perpendicular to y equals 3x plus 7 and passes through 6, negative 1. Well, perpendicular means we have to have the opposite reciprocal slope. So, our slope is 3 in our given line. So the perpendicular line slope is going to be negative 1/3. And then just like we did in our last examples with parallels, we're going to plug it in our point-slope equation. And then I just simplified. Negative, negative makes a positive. So if y plus 1 equals negative 1/3 x minus 6. I want you to try the second example. Okay, here our slope is negative 1/4, so the perpendicular slope is going to be positive 4. And when I plug that into my equation, y minus 5 equals 4x minus 2. And there's an equation that is perpendicular through the given point. Couple things to think about. Now, we talked about perpendicular and parallel lines, but what about these odd equations? We talked about special linear equations. How do we write lines perpendicular and parallel to this? Because this is going to be really helpful when we get to geometry. Well, think about the line x equals 3. X equals 3 is a vertical line. So what type of line is going to be parallel to a vertical line? Hopefully, you said horizontal. And that's right. The slope of a vertical line, well, it's undefined. So the perpendicular slope is going to be 0. So when I'm going to write a line perpendicular to x equals 3, it's going to be any horizontal line. So it could be y equals 4, y equals negative 2, y equals 1,000,000. As long as it's a horizontal line, they'll be perpendicular. Now let's think about what are we going to do when it's parallel to that. So parallel to a vertical line is going to be another vertical line, which means my slope is still going to be undefined. And any line that's got an undefined slope is going to be parallel. So x equals 15, x equals negative 6, x equals negative 106. Any of those would be parallel to the given line. How would you write a line perpendicular to y equals negative 4? Well, we kind of talked about that. Perpendicular to a horizontal line is going to be a vertical line. So my slope is 0. My slope of my new one is going to be undefined, which means my equation is going to be x equals whatever value you want. X equals 15, x equals negative 6, any type of value you'd like for x. And parallel, well, now they're going to have the same slope, so their slope is 0. So anything that's parallel will be y equals 3, y equals negative 14. So it's easy to write parallel and perpendicular lines if you understand the relationship between horizontal and vertical lines. They're always going to be perpendicular to each other, and they're going to be parallel to themselves. So if I wanted you to write a line perpendicular to a vertical line at a certain point, you guys could easily do that now because you understand how perpendicular and parallel lines work. We're going to continue working on this in class, but that's it for the night. Nice job, and we'll see you tomorrow.